you. Hello, and welcome back. We are going to expand our information on the metric system today. So the last lesson we talked about just the metric system in general and those base units that we use. The thing is that there's a lot of instances in science where you want to go from one unit to another, and you need to be able to see how those units relate to each other. This means that you need to be able to convert between units. So if you want to know how many grams there are in a kilogram or how many pounds there are in a kilogram, that's what we're going to look at today. So at the end of this lesson, you should be able to convert between metric units. So for example, going from grams to kilograms. And you should also be able to convert between metric and US units. So going from kilograms to pounds. So in your summary, here are some questions that you will need to be able to answer. How can you convert between the metric units using the staircase method? You're going to need to be able to describe that in detail. You're going to have to show your work when you do these problems. How can you convert between metric units using conversion factors? And then how can you use conversion factors to convert between metric and US units? And there's also some common metric to US conversions that you will need to know. You won't necessarily have to memorize these, but you need to be aware of them and know when to use them. Let's start out inside the metric system itself. There are a few ways we can go about this. Today we're going to talk about the staircase method and conversion factors. The first method works really well when you are converting units that are fairly close to the base unit. Start by writing out the prefixes in order. Now remember that the base unit is the ones place. These are the units that you are using to measure, either grams, meters, or seconds. To the right, we have the deci prefix, which means 1/10, followed by centa, or 1/100th, and then milli in the thousandths place. Notice how each one of those prefixes adds a decimal place to the right. On the other side of the base unit, we have increasing prefixes. Deca means 10, hecta stands for 100, and then we have kilo, which represents 1,000. I again want to point out that the place value of our numbers are changing by 10, and if we're going to the left, the values are increasing. In this method, to convert the given unit to a smaller unit, we are going to move the decimal to the right. What we are really doing is multiplying by our measured number by 10 for the appropriate number of places. So let's say, for instance, that we want to convert 0.15 meters to centimeters. Meters is one of our base units, so we start on the staircase there in the middle with the base unit. To get to the centa prefix, we need to move to the right. One space to the right is deca, so we need to move one more space to get to centa. This movement represents the movement of the decimal place 2 points to the right. This movement represents the movement of the decimal point 2 places to the right. So we are going to take our decimal point and move it 2 spaces to the right. This gives us a resultant number of 15. So there are 15 centimeters in 0.15 meters. I do want you to take note here that when we move our decimal to the right, we are multiplying by 10 for every prefix. So moving from meters to decimeters, we would multiply by 10. Moving from decimeters to centimeters, we would multiply by 10 again. So overall, moving from meters to centimeters moves us 2 prefixes, each representing 10, so 10 times 10 is 100. In the end, moving from meters to centimeters means that we are going to multiply by 100. This makes sense, since centimeters is a smaller unit, we would have more of them. What if we want to go from a smaller unit to a larger unit? Say we want to know how many grams there are in 4,586 milligrams. Where are we going to start? Our starting unit is milligrams, so that's our starting prefix on the staircase. We want to convert to grams, which is a base unit. To get from the milli prefix to the base unit, we are going to have to move through 3 prefixes, and the base unit is to the left of the milli prefix. So where is our decimal in the number 4,586? It's not shown, but it is understood to be at the end of the last number. So we are going to start after the 6 and move our decimal place 3 places to the left. This puts our decimal place in between the 4 and the 5 of our number. So 4,586 milligrams is equal to 4.586 grams. Since the decimal place was moved to the left, our number got smaller. All right, so let's look at these. 5,876 meters. We want to know how many kilometers that is. So kilometers is to the left of meters on our scale, and kilo means 1,000, so it's 3 spaces. So we're going to move our decimal 3 spaces to the left. The decimal point is going to be after the 6. So 5,876 meters will equal 5.876 kilometers. 250 grams, the decimal point is going to be at the end of the 0. Grams is our starting unit. We're going to go to kilograms. So again, kilo is 3 spaces to the left of our base unit. So we're going to start at that 0, move 3 spaces to the left, and we're going to have 0.250 kilograms. Now, one thing I do also kind of want to point out, this 0 right here, it's always a really good idea to put that 0 in front of the decimal point. The decimal point is usually pretty small, and that can get lost. So it's a good habit to get into to put that 0 when you have a decimal. 987 centimeters. So centimeters is our starting unit. The meter, so meters is 2 spaces to the left of centa. So we're going to start after the 7. We're going to move our decimal 2 places to the left. So 987 centimeters is 9.87 meters. 357 meters into millimeters. Meters is to the left of millimeters, so we're going to start with meters and move to the right 3 spaces to milli. And again, we're going to start there after the 7. So there's nothing there after that number. So we're going to fill in those spaces with zeros. So if you ever end up with spaces where there's no number, those empty spaces here where we've moved our decimal point, you're just going to fill in with a 0. Okay, so that's your staircase method. A second method we can use to convert between units is by using conversion factors. A conversion factor is simply a number that is used to convert one set of units to another. A conversion factor consists of 2 values that are equal to each other but expressed in different units. So for example, if you have a dozen eggs, how many eggs do you have? You probably know that a dozen is simply another way to say that you have 12 eggs. But what if we had 42 eggs? How many dozen would that be? Now, you can probably do this in your head, but think about what the process is that you are actually going through to get the answer. You are using a conversion factor. The conversion factor is given as a ratio or fraction that can be used as a multiplication factor. What I want you to notice here is that these fractions that we have written are actually both equal to 1. If you have 1 dozen eggs, you have 12 eggs. Those 2 values are the same thing. What is one value over itself in a fraction? It's 1. If you have 4 over 4 in a fraction, that fraction is 1. So if you have 12 dozen eggs over 1 dozen eggs in a fraction, that value is still 1. What this does is it allows us to multiply a number by this fraction, and what we are really doing is just multiplying by 1. So let's go back to our 42 eggs. How many dozen is this? Well, we can now multiply the 42 eggs by one of our conversion factors. But which one? Let's look at this first one. If we take 42 eggs and multiply it by 12 eggs over a dozen, we get 504 as our answer. That doesn't really seem right. 504 dozen eggs is a lot of eggs. So how could we know which factor to use before doing the math? So here's a hint when you're working with conversion factors. Look at the labels. Labels in science is a fascinating thing, and they behave in much the same way as numbers do. If we multiply across, we get eggs times eggs, or eggs squared. In the denominator, we have a dozen. So our label ends up being eggs squared over a dozen, and that doesn't make any sense. But what if we bring this other conversion factor down and use it instead? What happens now? Now we get 42 times 1 divided by 12. The answer here is 3.5. Okay, so first off, that number seems a lot more reasonable. If a dozen represents 12, we should not have more dozen than we have total number of eggs. But what about our label? Looking at our problem, we have eggs on the top and eggs on the bottom. What would happen if we had 7 on the top and 7 on the bottom? The 7s would cancel out. The same thing happens with labels. If we have eggs on the top and eggs on the bottom, the eggs will cancel out. That leaves us with a dozen. Conversion factors can be used to convert between prefixes in the metric system as well. So let's go back to our how many centimeters are there in 0.15 meters? Well, we know that there are 100 centimeters in 1 meter, so we can use that as our conversion factor. But which version should we use? We are going to multiply by our known value, which is meters. So we want to use the conversion factor that has meters on the bottom. This will cancel out the meters and leave us with centimeters on the top, which is perfect. Now we can multiply across and we get 15 centimeters as our answer. Now, in order for this to work, we need to know the values of a measurement in different units. So here are a few that we will run into quite a bit. 1 inch is equal to 2.54 centimeters, while 1 mile is 1.61 kilometers. A pound is 454 grams. 1 kilogram is 2.2 pounds. So these are pretty common conversions that we're going to be using in our classroom, so you want to remember these. So let's look at this in terms of going from metric to US or vice versa. Let's take our 0.15 centimeters, and we want to know how many inches that is. Well, we just found out that 1 inch is equal to 2.54 centimeters. So we can write our conversion factor either as 2.54 centimeters over 1 inch or 1 inch over 2.54 centimeters. So which one are we going to use? We want to know how many inches there are in 0.15 centimeters. So we're starting with centimeters. Centimeters is on the top. We want the conversion factor that has centimeters on the bottom so that those units cancel out. So we're going to bring this 1 inch over 2.54 centimeters down. That's going to cancel out our centimeters. So we're going to multiply by 0.15, 1 by 0.15, and then we're going to divide 2.54. That's going to give us 0.059 inches in 0.15 centimeters. All right, so it's your turn. Here are 4 problems. You are converting 5 kilometers into miles, 250 pounds into kilograms, 5 feet 6 inches into centimeters, and 987 inches into meters. So pause your video, take a minute and work through these, and we'll see how you do. So in the first one, we found out that 1 mile was equal to 1.61 kilometers. And we knew kilometers and we're trying to find miles. So we would use the conversion factor that had the kilometers on the bottom. So 5 kilometers is 3.1 miles. On that second one, we know now that 1 kilogram is equal to 2.2 pounds. And we started with pounds. So our conversion factor is going to be written so that pounds is on the bottom. So 250 pounds equals 114 kilograms. Okay, now this one was a little bit tricky because 5 feet 6 inches actually has 2 units in it. We know that 1 inch is equal to 2.54 centimeters. So what we can do is we can convert that 5 feet 6 inches into inches. So that we know that there's 12 inches in a foot and there's 5 feet. So we have 12 times 5 is 60 plus our extra 6 inches. So we have 66 inches times 2.54 centimeters gives us 168 centimeters. And then the last one, you have 987 inches. How many meters is that? Well, we know that there are 2.54 centimeters in every inch. So we can convert 287 inches into 2,507 centimeters. But what was the question? The question was meters. So how many meters are there in 2,507 centimeters? So remember from the beginning, now remember our staircase method from the beginning. We know that centimeters is 2 places to the right from a meter. So if we want to go from centimeters to meters, we would have to move our decimal 2 places to the left. So 2,507 centimeters is going to be 25.07 meters. All right, so how are we doing today? Today, we talked about how to convert between metric units, and we talked about how to convert between metric units and US units using 2 different methods. So think about, are you able to do those 2 things? In your summary, these are your questions. Know how to convert, describe how to convert between metric units using the staircase method, and how to convert between metric units and metric and US units using conversion factors. And make a note of those common metric US conversions that you're going to need to know. You won't need to memorize those. We talked about that a little bit. You won't need to memorize those, but those are going to be things you're going to have to recognize that you know it. So you'll have that information available, but you have to recognize that, yes, I do have that information. And then don't forget your question.